Okay, welcome everybody. So here's 6.1, right? A new section, slope intercept equation from a graph. So this one we want to learn how to construct linear functions. So we're going to write a linear function in slope intercept form given its graph. Okay, so constructing, and we're going to apply this. So what is a symbolic representation for this graph? So let's think about symbolic representations, right? So we use an equation. And we always use the equation y equals mx plus b, right? That is our slope intercept form, right? So slope intercept form, and we always know that our m value is our slope, which is also our rate of change. And then we know our b value is our y-intercept, which is always our initial value, right? So when we want to write an equation, we always start at the initial value. So we look at our graph, where does it start, right? So if we know our function, so it starts at 0 seconds, right? And the elevation is at here, this point right here. So this is our y-intercept, which is our initial value. So we look at what number that is, right? So each line, it goes by 500s. Like this will be 7,500, 8,000, and then 8,500, right? So our y-intercept is going to be 8,500, right? And this is in meters. So 8,500 meters, right? That's our y-intercept. Then we look at what is the slope, the rate of change. So we go along our line until we hit a corner. So here's a corner, could use that one. We go down, here's a corner, could use that one. I'm gonna use the second one because it lines up perfectly with 200. You could do the other one too, right? So either one, as long as it lands in the corner. So we go down, right? Our rise over run, because our slope is our rise over run. So we raise or went down, right? So negative. So it went down 1,000. So negative 1,000. So negative 1,000. And this is meters. And it ran or went to the right 200 seconds, right? So this is plus 200. So 200 seconds, right? Positive. So now we can simplify that or divide that, right? Negative 1,000 divided by 200 is negative 5. And this is 5 meters per second, right? So negative 5 meters per second is going to be our rate of change, which is also our slope, right? So now we can just write the equation for it, given that. So y equals negative 5x plus our initial value, 8,500. And that is our equation. You also can write in function notation form, f of x equals negative 5x plus 8,500. And it matches the graph because you can tell. Starts at 8,500 on our graph, 8,500, right? And it's decreasing, so it's negative, and it goes down 5 for every second. 5 meters for every second, or 500 for every 100 seconds, right? 500 for every 100, 500 for every 100. So you can tell it matches your graph. All right, so number 2, same thing, right? So we always going to compare it to y equals mx plus b. So we want to look at what is the slope, what is the rate of change. So always start at your initial value. So look at where does it start on our graph? Right here, right? And that's at 10. So this is our y-intercept, right? So our y-intercept is equal to 10, and this is in millimeters. So 10 millimeters. So no, that's 10, and our b is 10. That's our starting value. Then we look at what is the rate of change. So we go along our line until we hit a corner. Has to be a corner right there. So that's our corner. So we're going to look at our slope, right, which is rise over run. So we're just going to count how far did we go up. So we go up here. So that's 10, 20, 25. So this is positive 25. So positive 25 millimeters. And then we ran 10 weeks, right? 10 weeks. 10 weeks right there. So this is positive 10. So that's our rise over run, 25 over 10 And then we simplify that, divide the top by 5, we get 5, divide the bottom by 5, we get 2. So 5 over 2 millimeters per week. Okay? And that is our rate of change right there. So that's our slope. So it's 5 over 2 right there. So we have our initial value 10, our slope 5 over 2 because it's increasing, going positive, and we just write the equation. Y equals 5 over 2x plus 10 because it's positive 10. And that's our equation. So we put it function notation, f of x equals 5 over 2x plus 10 right there. And that's it. Okay, so you guys can do the next one. You guys try that one. Start the initial value and then see how far it goes down. Okay, and how to apply it to mathematical numbers, right? That's the application from it. So same thing. We always start y-intercept, right? So we're always looking at y equals mx plus b. What the intercept is. So we look, crosses the y-axis, right? This line right here. This is our y-axis. So this is our y-intercept. And this is equal to 3 because it's at 3. Or your ordered pair, which is 0, negative 3. That's your ordered pair. And then you look at what is a slope. So it's looking at it. You can tell. So your slope should be negative because it's going down to the right, right? So it's negative something, negative something. So you look at this point, and we go until we hit a corner right there. So we count down, right? Minus 2, right, is positive 1. So our slope is negative 2 over positive 1, which is just negative 2. So our slope is negative 2, and that makes sense. And we put it into our slope intercept form. Y equals our slope, which is negative 2, next to x, and our y-intercept is negative 3, so minus 3, and that's our equation. Okay, so make sure you label your rise over run on your graph. Okay, same thing. Start with our y-intercept. Right, we look at where does it cross this y-axis line. Crosses right here. So y-intercept, and that is at 5. Okay, so once you have the y-intercept equals 5, right? So y-intercept equals 5. Then you find what the slope is. So you go along your line till you hit a corner right there, and you count. So rise first, right? So it goes down 5, right? So negative 5, and it goes right 2, so positive 2. So your slope is negative 5 over 2. Right there, negative 5 over 2. And that's your slope. So your y-intercept, your slope intercept form is going to be y equals your slope, negative 5 over 2, next to the x, and then your y-intercept is positive 5. Okay, so let's try a number 5. So we look at number 5, right? Same thing. We look at where does it start on our y-axis, right there. So that's at negative 2, right? So y-intercept equals negative 2. And then we look at where does the slope go. Then we go, so we hit a corner right there. So we look at what is the rise, right? Plus 1, up 1. And we write right 2, so plus 2. So our slope, the rise of our run, is going to be up 1, right 2. So it's 1/2. So our slope is positive 1/2, and it's going up to the right. So that makes sense. So in our slope intercept form, again, compare it to y equals mx plus b. So we get y equals our slope 1/2 next to the x, and our y-intercept is negative 2. So we get minus 2 at the end. And that's our slope intercept form. Okay, let's look at a problem like number 6. So number 6 has a vertical line. So let's try to identify what is the y-intercept. So here's our y-axis, right? And our line is vertical, so it will never touch our y-axis. So we don't have any y-intercept, right? So this is none. Our slope, if you remember what our slope is, right, is rise over run. So let's look at a point. So let's say we started here. If we rise 1, how would we run, right? We cannot run. There's no run, so that's 0. So if we rise 1, our run would be 0. If we rise 2, our run will still be 0. Rise 3, our run will still be 0, right? So it's always over 0. And remember, if you divide by 0, you get a calculator error, right? It's undefined. Because you cannot divide anything by 0 because it doesn't make sense, or how many zeros in one? Can't really calculate that. So this is undefined. So slope is undefined. And then how do you write a slope-intercept form equation? Okay, so let's break this down into points. So this point is 5, 0. This point is 5, 1. This point, 5, 2, right? And this will be 5, 5. We can go the other way. This will be 5, negative 4. So if we look at all those points on our line, what is common about all those points, right? If you look at it, they all have an x value of 5, right? So no matter what point we choose, our x values will always be 5. So how do we write that as an equation, right? So when we say x is always 5, we just put x equals 5, and that's our equation. Yeah, so whenever you have a vertical line, let's say a vertical line here, now it's passing through 3, so this should just be x equals 3. Say it passed through negative 2, so this would just be x equals negative 2, right? So whatever your vertical line is at on your x value, that's the equation. Something that may look similar, number 11, now we have a horizontal line. So now we know there is a y-intercept right there. That's at 4, right? So our b is 4. Then we look at what the slope is, right? And our rise over run, if we look at it again, right, there's no rise. We cannot go up or down. So rise is 0. Our run could be anything. It could be 1 or 2 or 3, right? But the point is you don't go up or down. So rise is 0, and then 0 divided by any number is still 0, right? And then you can write this in your slope intercept form, y equals mx plus b. And then y equals our slope, which is 0 next to the x, and our y-intercept is 4. Well, then 0 times any number again is still 0, right? So it'll be y equals 0 plus 4 would just be y equals 4. So our equation will be y equals 4, because we have an intercept of 4, but we don't have an x because the slope is 0, right? Because 0 times x is just 0, so it disappears. And if we compare it to other numbers, let's say we had horizontal line here, this will just be y equals 2, right? Or here, this will just be y equals negative 1 if it was a straight line. And then right here, y equals negative 3, right? So wherever horizontal lines are, it's y. Whenever you have a vertical line, it's going to be x. So those are two differences between horizontal and vertical lines. All right, so you can guys do the rest. Make sure you show your work and then create it. Next one. So you create your own graph, then write the symbolic representation for your graph.